Good morning. Me and my friend Janil, we are going to present our project, whose topic name is Smart Agriculture. This comes under Smart Grid. So we are Team 20. And first of all, we will talk about the abstract. We are going to use IoT-based wireless sensor system to know the atmospheric conditions around plants and farm, and we will forecast weather, which will help the farmers so that they can plan their farming accordingly. And in this, we will depict all the data on a site, and then we will process accordingly by analyzing the data collected from the surrounding of plants. So we will now talk about the introduction of project. So smart farming is the way by which farmers can upgrade and enhance more productivity in their farming procedure. This project is based on Arduino and Wi-Fi Shield, and it will function with the help of different sensors such as temperature, moisture sensor, and send the real-time data to the server from which to the web page, and through that farmers can see and evaluate according to that they will plan their farming. The objectives for this project are mainly three: provide effective decision support system, minimum cost, user friendly system. And the motivation are main three: reduce wastage of water, make farmers life more better, increase crop yield. Now we'll talk about the components. There are majorly six components: soil moisture sensor, temperature sensor, humidity sensor, LDR, Wi-Fi shield, and Arduino. Now my friend Janil will explain.
So this is the soil moisture sensor. As you can see, there is these two probes which are connected to this miniature circuitry. So these probes go into the soil to measure the moisture. So basically, so this sensor can measure moisture content in the soil based on the change in resistance between the two conducting plates. The resistance between the two conducting plates varies in an inverse manner with the amount of moisture present in the soil. And it is also connected to the analog port. So the output is shown in analog voltage, which ranges from 0 to 1023. Next slide. Next slide.
Yeah, I have changed to humidity and temperature.
Okay. Humidity and temperature sensor, which is measured by the DHT11 sensor. So it basically measures the relative humidity, which is the amount of water vapors in the air versus the saturation point of water vapor in the air. So the range from which the temperature can measure is 0 to 50 degrees Celsius, and humidity from 20% to 90% with an accuracy of plus minus 1 degree Celsius and plus minus 1%. Next slide. This is the LDR, also called as light dependent resistor. So the LDR gives out an analog voltage which is when connected to the VCC, which varies in magnitude in direct proportion to the input light intensity on it. That is, the greater the intensity of light, greater the corresponding voltage from the LDR will be. Since the LDR also gives out an analog voltage, it is connected to the analog input pin on the Arduino. Next slide. Now my friend Harsh will
Yeah,
explain
I will
about
take on
Wi-Fi
from
shield.
here. Yeah, sure. So now we will talk about the Wi-Fi shield. So it allows Arduino board to connect to the internet using the 802.11 wireless specification Wi-Fi. It is based on SDG204 wireless LAN network, and it runs through IP protocol. Use the Wi-Fi library to write sketches which connect to the internet using the shield. The Wi-Fi shield connects to an Arduino board using long wire wrap headers which extends through the shield. This keeps the pin layout intact and allows another shield to be stacked on the top. Now we'll talk about Arduino basically. Arduino board designs use a variety of microprocessors and microcontrollers. The boards are equipped with sets of digital analog input and output pins that may be interfaced to various expansion board shields or breadboards and on other circuits. The boards feature serial communications interfaces including USB on some models, which are also used for loading programs. These basically can be programmed using the C, C++ programming languages using a standard API, which is also known as Arduino language. Now Janet will continue with circuit diagram.
So this is basically the kind of circuit diagram it is not exactly the way how which we have connected. It is just for representation purpose and to show how the connections are made. So like we have connected our DHT11 sensor on the fourth pin of the digital input pin, and the LDR we have connected to the A1 analog input pin of the Arduino, and the soil moisture we have connected to the A0 analog Arduino input. So this is basically the similar kind of representation with different uh, different sensors connected to different ports. Otherwise, it's actually the same thing. Next slide. So yeah, this is very important to show how the Arduino and Wi-Fi Shield are connected. As you can see, the top one is the Wi-Fi Shield, the below one is Arduino Shield. Both look very similar in representation. So the Wi-Fi Shield has to be superimposed on the Arduino. So the while doing the connections, whatever sensor and whatever pins you are going to connect in the Arduino, the same way you have to connect with the Wi-Fi shield after attaching. As you can see in the second picture, the both have been attached. Now you connect the sensors to the Wi-Fi shield in the same way you are going to connect the Arduino board. Next page. Next. So this is the block diagram, basic block diagram. First we use sensors, then we collect the data, then using the microcontroller, then the using the microcontroller, the sensor data is collected. Then through the Wi-Fi shield, we send it to the database and the MySQL database, and then send it to the web page, uh, hosted by localhost. So this is the model or the actual picture of the hardware model. This, as you can see, the blue kind of blue sensor, that is the DHT11 sensor. On the leftmost is the LDR, and in between is the rain sensor module, that miniature circuit you saw before. Next. These are the same photos taken from different angles. We have put the soil moisture sensor in the mud. As you can see, I have a jar of mud, so I've put that in that. Next. So here comes the code, Arduino code.
Yes, Anil, you can continue.
Yeah. So at the first, we have included some libraries. The first one is a library used for the DHT11 sensor. The second one is used for Wi-Fi shield and the Arduino to communicate. And the third one library is the Ethernet library for the Wi-Fi shield. That is, next we have set the MAC address. Then we have given the variables and defined at which pin we have joined the sensor. Then the next one is define DHT type DHT11. We have written this because in the DHT series there is one more sensor called DHT22 from the same library. So we have mentioned DHT11. Then again, float humidity, float temperature. These are the variables mentioned. Here we have mentioned the IP configuration of the local host, which is my system here. So we have mentioned these things. Next, in the void setup, we have set the baud rate. Then we have set the pins to input modes, the LDR and the soil moisture. Then we have begun the DHT sensor. Then here in the if statement, we try to connect our Ethernet shield or Wi-Fi shield to the internet. And one more thing, the Ethernet or Wi-Fi shield is directly connected into my Wi-Fi router. So that is how it goes into the network. Next, again, we have mentioned we have tried to read the sensor data like analog read and DHT read, humidity commands. So we have tried to read the data from the sensors. Next, here is the one function we have created, sending to PHP myadmin database. So we have written the function here. First one is trying to connect to the server, that is to the server. Next, we have tried to print the humidity, soil moisture, LDR values, temperature on the serial monitor, as well as send this to the database. So all these are commands for that. And here, if the connection to the server didn't happen, so it would have shown connection failed. So
Yeah, from now on I will take.
next is the HTML and the
Yeah.
PHP code, which Harsh will explain.
Yeah. So basically HTML, we have the document type HTML in which we have made a head which is having a title sensors which will show on the web page, except that we have imported some links which can specify the styles, CSS styles of the web page. We are having body and having their background with their color codes, and the font size are in pixels. We have visit, upper and lower parts which all have been specified with their pixels, margins, height, position, width. And we are having date which can be shown in 40 pixels font, and we have year which will be shown with font as 30 pixel and color with the color code specific to that, except that we are having clock also that will have its specific color code which will be shown on the web page, except that there are the measurements for border radius which is 100% means unit, height, position, right, top, width, all these things are given in pixel, except that hour and minute have been also defined, and their CSS styles have been mentioned with their specific color codes and their paddings across the web page. And now we will talk about the minute and hour radius, which is approx 5 pixels. Now we will talk about the origin, bottom, center. In this, what will happen is here also a style is mentioned. In that, color, float, height, padding, text with all type of things have been specifically mentioned. Now we will talk about the weather, which will be having padding 10 pixel, font size 20 pixel. After that, we will have keyframes, which will have 100% opacity, that is unit. After that, the A tag, which will have its own text styling, text decorate, color, font size, width. And after that, the style will be over. Now we will talk about the PHP code. PHP code specifically will help us to send the data from the Wi-Fi shield and database to the web server. So it will have a specific username and all those mentioned things, in which we will have MySQL query, where we will have localhost. Through localhost, data will be gone to web page. We will have username, password, and database also. In this, we will have sensor data in a query which we will make and select from that. After that, we will have result which will come from MySQL query, which is a table which will show different conditions and their outputs. While showing rows, the result will be fetched, and we will have 5 type of specific fields: 2, 3, 4, 5, 6, namely humidity, temperature, soil moisture, light, and time. And it will be having result which will be depicted on the web page. After that, we are again mentioning how they will be depicted, so their styles have been mentioned. After that, we will have if else loop, in which if field 5 name is greater than 500 means light is greater than 500, then it's a sunny day. If it's less than 500, then it's a cloudy day. It will basically be mentioned with its specific background colors which will depict according to the value of the field 5 name. After that, we will have field 4, in which if the value is greater than 70, then it will be mentioned that soil is too wet. If it's greater than 50 but less than 70, then it will be shown as it's perfectly watered. And if it's less than 50, then soil is too dry. Now we will have div class, in which we will have visit, which is class, and clock, sorry. In clock, there will be mentioned minute and hour, and in that we will have our standard Indian standard time zone, which is Asia Kolkata, which will automatically update. And in that we will show date, month, year accordingly. And after that, the default time zone as IST according to Kolkata. After that, we will again have the Davis style, in which it is mentioned that how those clocks and will be depicted on the web page. So they are having their special lower, upper, and all those things In that there are different things like temperature and info weather. All the things have been mentioned with their headings, subheadings like H2, H3 and all those things. Now, now at the last of the HTML and PHP, we will have light, which will have its updated ID as rain, and we will have class info as humidity, which is there mentioned after light and humidity. Uh, the class will end, and after that the body will also end. Now it's serial monitor output. Now Janil will continue. Hello.
So this is what we get in the serial monitor output. First one is the connected, which shows that this thing Wi-Fi shield is connected to the net, and then we get the as we have received the faulty humidity sensor. That's why the humidity value is showing none and temperature also none. So as you can see, soil moisture, it is showing some value 97.65%. Even light is showing some value 15. So uh, next one, this is the our PHP table which we have made. As you can see, humidity is a float, temperature is also float. But as you saw in the previous slide, we were getting not getting any kind of values nan. So the data type of the two nan and the float does not match. It gets conflicted. So that is why we feel that our data is not being sent to the database. Soil moisture, light, time, timestamp also we are trying to show. So this is the as we could not send the data to the database. So this is what we have inserted manually into the table, this data. As you can see, for humidity we have shown 56, temperature 34, soil moisture is 10. Next. So this is how the web page is actually shown. If it's we show that if it's a cloudy day, a gray background will come, soil is too dry. You can see the values also. The soil moisture 10%. We in the PHP code and HTML code we have mentioned the if else loop. So that is how it's affecting here. Humidity, light, temperature, soil moisture, even the time and date is also showing. So uh,
Yeah, Janil, you can show from your
yeah,
laptop, like by inserting practically.
yeah, 1 minute. So as we can see, this is the table created on the MySQL thing, MySQL. So the name of the table is the sensor data. The name of the database is Smart Agriculture. As we told, due to the problem which we think, the data is not being sent to the MySQL database. So we have inserted some manually inserted values. So I will show you one example. Like for humidity, we put the some random values. So for temperature, soil moisture, we put. So these three we have already put. The fourth one which we have put just right now, as you can see. So see, if you see, it is a sunny day. All the values have been updated here as per according to the values which we have put. So one more thing, one more example I would like to show. We'll put some values here. It was a sunny day because we have put the values above 500 or 550. Some if else condition we have put. So due to that, the color gets changed. So this is the value which we have included, the new one. As you can see, this is the previous values. This is the again the new values. One more example I would like to show. For the cloudy day, we'll show. We'll insert. So you can see the sixth one which we have included, the new one. See the cloudy day, the value went up below 500. So the background also changed. The soil is too wet because 80% we have set the limit as 40 to 70% as around moderate, and below that it is, and we have to water, and below above 75 70 it is too much watered. So this was the data we are trying to show. Now next PPT Harsh will share.
Yeah, sure. Yeah, can you see?
Yes.
Okay. So now
Future scope.
about the future scope. So future work would be focused more on increasing sensors on this system to fetch more data, especially with regard to pest control, and by also integrating GPS module in this system to enhance this agriculture IoT technology to full-fledged agriculture precision ready. Using the rain sensor, even an irrigation system can be designed for projection of the data, and application can also be made. Now, the conclusion of this project. Over time, agriculture has been affected by weather disasters, storms, and by natural disasters, and plant diseases have been caused because of that. So, IoT based solutions for monitoring of many parameters for better precision agriculture can help solve these problems. Such a system would provide useful information on plant growth, crops, diseases, and soil properties that are a benefit for crops. More number of sensors and features can be added to make this system more beneficial. These are the references which we have added, and thank you.